Okay, let's dive right into this. Welcome back, team. Today, we are taking a deep dive into the absolute core of our desktop experience, and that's the Silk Shell component of the Sex Sauce microkernel. As fellow engineers building this entire thing from the ground up, you know exactly how critical it is that we get this right. We're finally moving past the theoretical stuff, and in this explainer, we're going to look at exactly how we've hardened our capability routing and MPK isolation to make the Silk Shell a reality. So, let's get started. Here is our roadmap for today. We'll be hitting the Silk Shell architecture pipeline, resolving headless compositor black screens, averting Ring 3 null pointers, the frame-driven actor system contract, our strict invariants, and finally, our proven work and next steps.
All right, Section 1, the Silk Shell architecture pipeline.
Okay, let's walk through the exact proven execution flow from hardware input to visual output. This is explicitly laid out in our Phase 29C architecture pivot document. Think of it as a river. First, sex input captures the raw hardware HID events. Next, Silk Shell acts as a pure event reactor. It takes those events and generates our universal UI intermediate representation, or UIIR scene intents. From there, we cross the PDX capability edge, specifically using SLOT display and OPW endo create. And finally, SexDisplay, which is our deterministic state reducer, reads that intent and blits the actual pixels to the screen. It is a strictly one-way flow of information, no exceptions.
Now, what's really interesting about this slide is our exact capability routing map. Notice how Silk Shell is locked tightly under protection domain 3, utilizing hardware P key 3. It routes its visual intent strictly through PDX slot 5, which is the slot display. We've also got our specific gesture input handling rules defined right here. For instance, using a simple Control plus drag acts as a two-finger swipe to switch workspace view tags, and a left-click plus drag handles window geometry updates. Oh, and sitting over there in PD2 is Linen, our file manager. This table isn't just theory anymore, guys. This represents our hardened architectural reality.
Moving right along to Section 2, resolving headless compositor black screens.
I know we've all stared at that dreaded headless compositor black screen and just scratched our heads. Well, we hit a wall where our hardware MPK isolation was actually working too well. It locked PK1 perfectly, which is great, but our software capability routing table was totally empty. This completely severed the authorized IPC edge between Silk Shell in PD3 and SexDisplay in PD1. Because the system totally lacked a live capability binding graph, the GPU pipeline was essentially running on empty, with 0 draw calls submitted, hence the permanent black screen.
So, the hardware keys were tagged perfectly, but init.rs was totally missing the software wiring. To fix this, we basically went straight to the boot phase and wrote an explicit pd.grant capability patch directly into the init.rs spawn path. By statically wiring slot display to the compositor ID during the microkernel's boot up, we handed Silk Shell the exact authorized edge it needed, and boom, that single fix completely eliminated the black screen and permanently restored our cosmic purple background in the Silk Bar panel.
But fixing the wiring was only half the battle. We also had to tackle those nasty boot time races. Chronologically, take a look at these scheduler ticks. We successfully mitigated IPC priority inversion and starvation underload by strictly enforcing cooperative forward progress. So now, if Silk Shell attempts a PDX call before SexDisplay is fully initialized, the kernel capability gate explicitly returns ERR service not ready. Instead of spinning and wasting cycles, or worse, crashing, Silk Shell is mandated to call sys-yield-jued. It politely yields its time slice until SexDisplay finishes resolving its directed acyclic graph and marks the service as ready. This makes our boot sequence mathematically deterministic.
Next up, Section 3, averting Ring 3 null pointers.
I'm sure this crash log gives some of you nightmares. This was our next major system fix, stopping a catastrophic jump that was compromising our hard-fought isolation boundaries. Here's what was happening. When Silk Shell's capability lookup failed before the PDX grant reached the Ring 3 capability table, we'd get this catastrophic userland null pointer jump. The system blindly attempts to dereference address 0x0 right at the entry point of PD3, totally crashing the domain before it can even emit its very first telemetry pulse.
To fix this, enter our lifesaver, pdxcompositorclient.newSafe. This is a completely null-safe PDX client constructor. It formally validates the capability resolution checks. Specifically, it actively verifies that slot display actually exists in the local capability table.
If it's completely missing, it cleanly logs the error and halts the domain instead of blindly jumping into the void and dereferencing null. This completely averts the null pointer jump and ensures that Silk Shell safely enters ring 3 every single time.
Okay, Section 4, the Frame-Driven Actor System Contract.
Moving forward, we absolutely have to respect the rigid system architecture rules we've laid out, specifically emphasizing the Sex Saasos contract, which is our visual liveness guarantee. Let's break down the atomic frame barrier phases. First, we have ingestion, where Silk Shell is open to freely issue PDX calls. Second is the seal phase. Think of this like locking a vault door. SexDisplay wakes up and issues sysframe sealing, totally locking the queue. Third is render, where SexDisplay empties this sealed queue and computes the UI. Because the queue is sealed tight, the state is mathematically frozen. Finally, commit and flip. We increment the global epoch and unseal the queue. This rigorously proves that Silk Shell absolutely cannot leak frame n+1 state into frame n while SexDisplay is computing the pixels.
Section 5. Strict Silk Shell Invariants. Listen up, team, because we have to vigorously enforce these new rules. We all need to break our Linux user space muscle memory immediately, because Sex Saasos is fundamentally different. The contrast here is incredibly sharp. Under legacy POSIX assumptions, you think you automatically have a standard library, libc, threads, direct pointers, and you assume you can just write directly to the frame buffer. Not here. In our Silk Shell reality, we operate strictly without standard library or POSIX crutches. Communication is PDX IPC only. There are absolutely no direct cross-PD pointers, just bounded weights. And most importantly, Silk Shell is a pure state producer, totally stateless between frames. I want to hammer home this exact, non-negotiable invariant straight from our Sex Saasos Rust rules. Read it with me. Silk Shell never writes to the frame buffer directly. It emits render intents only via PDX. This is absolutely crucial to ensure no architectural regressions occur. SexDisplay is the sole owner of the frame buffer, guys. We must respect those server ownership boundaries at all times. Finally, Section 6. Proven work and next steps. We really need to clearly separate the mathematically proven architecture we've built from the immediate operational targets we need to hit next. So the crucial point here is that we have a hardened fabric. Our MPK isolation lock and PK3 routing for Silk Shell are completely live and stable. Our static capability grants are fully wired into the init.rs spawn path. Silkbar is successfully rendering, basic gestures are recognized, and those nasty ring 3 null pointer jumps are completely eradicated. Phase 25 is fundamentally proven. But obviously we're not quite done. Here are our exact next steps. First, we need to connect sex input normalized pointer events to Silk Shell so we can finally get real hardware mouse drag and resize proofs working. Next, we have to wire linen and PD2 via SLOT storage so we can navigate real files. And finally, we need to dynamically spawn app launchers into PDX slot 7 through 15 using SexShop. I need everyone intensely focused on wiring these input events and the dynamic app spawning.
And this brilliantly illustrates our path forward. I'm going to leave you with this highly technical, provocative thought. If we have completely unified capability and execution in this single deterministic execution substrate, how do we push this architecture to a single hardware-visible coherence domain for Phase 30? Seriously, how do we master zero-copy APC? That is our next grand challenge. Let's get back to the code, team.